injection well really produces an underground menace in our society. We have several different types of injection wells that you can see. First, there's deep injection wells. These come from nuclear reactors and things where they develop nuclear waste, where you inject it very deeply into the ground. These obviously produce very great hazards in certain areas where you'll be pulling out the water from that depth. On the other hand, injection wells occur everywhere. Anytime you put a positive pressure on any kind of waste that sits on the ground, it's going to be forced down into the ground. And so therefore these can be as simple as drainage ditches at the bottom of hills, or buried oil tanks in a house, or septic systems, or industrial waste. Any of these things, waste in a gas station, these things will all produce a positive pressure driving the pollutants down into the ground. This is the groundwater simulation apparatus. It's a modified terrarium in which we put layers of stratigraphy in it. The stratigraphy is a clay-rich aquiclude layer surrounding clay-poor aquifer layer. The aquifer has a high porosity and permeability. What we do is we bring in some water from a tap and fill in a tank on this side of the apparatus, which fills up with water. The water then flows through the aquifer layer, coming all the way to this side and then exhausting out of this tank on the side through a pipe into the sink. What we have on top is a series of wells. The well on this side, which is closest to the input side, is an injection well. This is where we were going to dump our dye in to track it. Down below here is a field of monitoring wells. The monitoring wells make 12, and this is where we're going to test the pollutant as it moves through the aquifer. At the bottom end we have a stream cut into the stratigraphy into the aquifer, in which water flows from the ground into the surface water system. In here then we'll be able to show how the pollutant moves underground and in addition moves through this stream. Okay? I'm going to invite the students to come in now and show them how we're going to run the experiment. What you're going to do, students, as I run this through, I will put the slug of dye into the injection well up at the top. We'll use a blue dye. And what you will do is I will call time. And each of you will handle 2 wells, and you will withdraw a sample of the water from the well. You will stick this water in the test tubes that you have, and then you will take your test tube over and compare it with this calibration chart on this side. And the number you read on the top is what you will get for that particular test. If there's no color, it's a 0. Everything else goes 1 through 10. Okay, then we're going to take that number and you'll read it off and we'll put it on a chart on the board. After you've done that, you take your sample and dump it into the sink. Okay, so you clean out your test tube for the next sample. Okay, so that's the way we're going to run it through. I will first start with the slug of dye and time it 4 minutes before we take our first sample. Okay, now we're going to have a spill going on. The large chemical company in your town is now spilling all kinds of chemical into the water. Do you see any coming out of the back there? Nope. Okay. Okay, there's our spill. Notice that the dye has now gone down into the water table and now can start moving through the aquifer as we go through. Now I'll keep track of the time on this and I will tell you when we start taking our samples. All right, time. Okay, for purposes of speed, I'm going to do the correlation rather than normally students can do this. Makes it much easier, but for the area we have now, I'm going to do the correlation just by looking at these visually. Does anybody have A? Who's got an A? Okay, A is 0. B? Okay, B is 7. C? C is 0. D? D is 0. E? is 0. F is 4. G is 2. H is 0. I is 0. J is 0. K, 0. L is 0. There you are. Okay, normally students would come around and do that same process themselves by correlating the color by the tone that we have on these charts. Okay, time. Okay, this is the second test now. They've waited 3.5 minutes or 4 minutes, depending on the tank, between each one. And now we're going to take a second sample of this to see how much farther the plume has moved underneath the ground. Okay, who's got A? Okay, A is a 7. This is B. B is a 10. C. C is a 5. D. D is a 2. E. E is a 10. F. F is a 3. G. G is a 2. H. H is a 9. I. I is a 0. J. J is a 0. K. K is a 3. And L. L is a 0. Okay, and that's the second test. You can see the last test that now things that were originally very high are beginning now to get low again. So we now can see that the slug has passed through some of the wells, and we now coming out of the bottom and going through the stream at the other end of the tank.